Going from 84 feet above sea level to 3 feet above sea level, you will notice the water blocking the majority of the island. I wonder why. This bottom photo cannot be seen on a day when there's no refraction. However, the refractive properties of the atmosphere can make the bottom photo possible. On a day without refraction, one will not see the island from sea level. The bottom photo is an example of a looming towering mirage. Note the difference between 84 feet and 3 feet above sea level. This video was taken by James Mann at the Bay of Fundy looking at Isle Haute at 27.3 miles away and Nova Scotia at 44 miles away. This is an example of a looming mirage. Most looming mirages occur over large bodies of water which are colder than the air above. Bending of light rays increases as the temperature gradient increases in the air layer. The greater and deeper the inversion, the higher the object appears in the sky because our eyes think the light is straight. Note the towering of the bottom photo when compared to the top. This is real refraction happening. Here's an example of looming on the top photo. The second photo shows towering with looming, which increases and stretches the height of the distant object. Fata Morgana occurs due to rays of light are bent when they pass through the air layers of different temperatures in a steep thermal inversion where an atmospheric duct is formed. This is common in the polar regions. Looming is the most common of the three. It is a large refraction of the object that increases the apparent elevation of distant objects and sometimes allows observers to see objects that are normally located below the horizon under normal conditions. Colder, more dense air remains near the water, while warmer, less dense air is above the cold air, creates the conditions for the light to bend and to see objects over the horizon. Conditions vary. You may have weak, medium, or strong refraction. You will clearly see refraction and curvature all in the same video. Mr. James Mann, please show us some curvature, as well as some refraction.
Hello everyone. It's New Year's Eve, and so it's time for one last flat earth proof for 2019, and this proof comes from James Mann in Canada. The two videos that we're going to take a look at were from two different camera positions on a beach in New Brunswick, Canada. The coordinates are listed here. From the two camera positions, James filmed both the Isle Haute in Nova Scotia, Canada, and the mainland of Nova Scotia. This is the Isle Haute in Nova Scotia. It has a maximum elevation of only 300 feet. The Isle Haute was 27.3 miles away from the two camera locations. At the first elevation of 84 feet, using the official globe math, the Isle Haute should have been hidden by 172 feet.
He forgot to add one variable flat earthers hate to use. Refraction.
Certainly doesn't look like 172 feet of this island is missing. So how much of the island do you think is hidden behind a purported Earth curvature? I cropped this image to that far right point on the island was 27.7 miles away. Under the globe math, the maximum distance to the horizon should have been under 11.2 miles, and yet it's further than 27.7 miles. The only counter-argument of the globe cartoon religious zealots is that you're looking at a mirage of half an island that has hopped the curvature and the bulge of water in front of the island disappeared and then reappeared behind the island, creating a new horizon line, which is also a mirage.
First we'll put in 27.3 miles for distance to the target, then we'll put 84 feet for the observer height, and then we'll put 328 feet for the target's height. Now with no refraction, 172 feet is hidden, but 155 feet is shown. With weak refraction, 188 feet is visible and 139 feet is hidden. Now with standard refraction, 196 feet is visible and 131 feet is hidden. Now with intense refraction, 220 feet is visible and 102 feet of the island is not visible. Now with strong refraction, 246 feet is visible and 81 feet of the island is hidden. Note, can be observed is on the bottom.
Now, do you understand why I consider globalism a crazy cult? But let's keep going. Also visible at the first camera position is the mainland of Nova Scotia. Looking at the right or western side of Nova Scotia, you can see that it was slightly obscured by a mirage mirror, and that's why it looks like it's floating a bit there on the right, but the video nevertheless still destroys the globe. No, my globe faithful, a mirage is not curvature, despite how many times you click your heels and wish it was. Using Google Earth, I drew a line at the west side of Isle Haute. The closest point visible was 44.4 miles away. Under the globe math, 735 feet should have been hidden.
Okay, let's change the target distance to 44 miles with the height at 84 feet and the target height at 700 feet. With zero refraction, all of Nova Scotia will be hidden. Now with weak refraction, 93 feet of Nova Scotia will be visible and 606 will be hidden. Now with standard refraction, 119 feet would be visible and 580 feet would be hidden. With intense refraction, 218 feet of Nova Scotia would be visible and 481 feet would be hidden. Then you can see here with strong refraction as well, and polar refraction. Even with weak refraction, Nova Scotia in the background can be seen from 44 miles away from a height of 84 feet.
But from James's first observation point, the highest point of Nova Scotia west of that line was at a maximum height of 710 feet. Nova Scotia should have been hidden, entirely hidden, behind an imaginary curvature. There's simply no visible globe curvature, and James debunked the globe before even leaving the parking lot. But let's get to the second camera position. After James bravely hiked down the 80-foot ridge to the beach while continuing to film with his P900, go and watch it on his channel to see the uncut footage. The distance from the second position was still 27.3 miles away from Isle Haute. For the second position at the beach, James brought his camera down to just 3 feet off of the water. At that elevation, under the globe math, a huge 422 feet of the island should have been hidden. Remember, the island only had a maximum height of 300 feet. There is a slight mirror mirage creating some obstruction, but the island is obviously still there when the top should be 122 feet below the horizon. Again, the globe lie is busted. Thank you, everyone, for watching.
Here we go. The distance 27.3 miles with the 3.5 feet above sea level for observer height and 328 feet for the target height. Okay, with no refraction, the island cannot be seen at all. Okay. Now with weak refraction, the island still cannot be seen from sea level. Now with standard refraction, the island is still hidden. Now with intense refraction, 23 feet of the island is visible, which coincides with the photo taken from sea level. That gap on top of the island is about 25 feet tall. This is intense refraction, common over large, cold bodies of water. Now with strong refraction, 61 feet of the island would be visible from sea level. With polar refraction, about 2/3 of the island would be visible from sea level. With the bottom photo, you cannot see the hills 44 miles away from 3 feet above sea level due to curvature of the Earth. Let's plug in 44 miles for the target distance, 3 feet for the observer height, and 700 feet for the target height. From no refraction to intense refraction, you will not be able to see Nova Scotia from 3.5 feet above sea level at a distance of 44 miles. If this was polar refraction, you'll be able to see the upper half of the mountains in Nova Scotia. Nova Scotia is not visible from sea level due to Earth's curvature. The Earth's surface is blocking the island in the bottom photo with refraction revealing only the top 20 feet of the island. Without refraction, the island would not be visible at 3 feet. That gap is in between the trees. Notice the towering stretching effect in the bottom photo when compared to the top photo. A special thank you goes to Mr. James Flat Earth Mann for demonstrating the Earth is a sphere and not flat.